Hello, good morning. Good morning. This video is mainly dealing with the topic light reflection from the subject physics. There are different topics in this chapter. First one is spherical mirrors. There are two types of spherical mirrors. One is concave mirror and another one is convex mirror. There are some terminologies related to this concave mirror and convex mirror, such as pole, center of curvature, radius of curvature, principal axis, focal point or focus, etc. Then after that, if the object is at infinity, what happens to the rays to the concave mirror and the convex mirror? Then, based on the position of the object, the uh, the characteristics of the image, what about the size of the image, the nature of the image, the position of the image. Sometimes the image will be enlarged. Sometimes the image will be diminished. Sometimes the image will be at the same size of the object based on the position of the object. We will discuss that. Then another important topic is called a ray diagram. Uh, you should draw rays like this based on the question. You have to draw rays like this. When you draw the ray diagram, see, this law is very important. We know this law. What is this? I is equal to R. Angle of incidence will be equal to angle of reflection. So we will discuss the ray diagram of two mirrors, such as concave mirror and convex mirror. Then there are different cases we will discuss. Then after that, we will discuss the different positions of the object. Based on the different positions of the object, what happens to the image? Is it inverted? Is it erect? Is it virtual? Is it real? So we will discuss all those things. Then what are the applications of concave mirror? Then after that, we will discuss the formation of image by a convex mirror. Then we will see some questions related to this chapter. Then sign convention, this is a very important. We have two types of problems. Surely in your exam, two questions from mirror formula and magnification. So you can expect problems from mirror formula and magnification. So before solving the mirror, before using the mirror formula uh, and magnification, you should apply the sign conventions properly. Okay, so sometimes it will be plus, sometimes it will be minus. Okay, so if your sign convention is wrong, your final answer will be wrong. So this sign convention is very important. We will discuss the sign convention. Then after that, we will discuss the formula. 1 by f is equal to 1 by u plus 1 by u. This is called a mirror formula. Then after that, magnification, height of the image divided by height of the object. We will discuss that. Then after that, we will see some problems related to this mirror formula and magnification. And we will see some more problems like this. Some problems related to sign conventions. And finally, there are some problems related to, we will apply this mirror formula. 1 by f is equal to 1 by u plus 1 by u, 1 by u. Then we will use this magnification formula. M is equal to height of image divided by height of object is equal to minus v by u. We will use those equations and we will solve some problems. Okay, so that's all about this chapter. Okay, let's start. So we will start with the spherical mirrors. Okay, so spherical mirror means, or spherical mirrors means, as the name indicates, spherical. Spherical means what? Sphere, like this. Okay, there is a sphere. Okay, and mirror is a part of this sphere, right? For example, here you can see this is the part of this sphere. That's why this mirror is called a spherical mirror. Okay, so we know that in a sphere there is a center point that is called a C. This is what is called a center of curvature. And for example, if the reflecting surface is inside, this is the reflecting surface. If the reflecting surface is inside this sphere like this is what is called a concave mirror. This is called a concave mirror. If the reflecting surface is outside, for example, if the reflecting surface is like this outside, this is what is called a convex mirror. Okay, so reflecting surface will be outside. Reflecting surface. Okay, so these two mirrors are a part of a sphere. That's why this is called a spherical mirrors, where a C is the center of the sphere, and this is called a center of curvature. And here, this is called a P, and this is my mirror, and this is the center point of this mirror. This is what is called a pole. Okay, and this is the pole of concave mirror, and this is convex mirror, and this is the pole of convex mirror. Okay, if I'm joining these pole to center of curvature of this convex mirror, this is what is called a principal axis. This is called a principal axis. Okay, and this is the principal axis of concave mirror. This is the principal axis of concave mirror. Okay, there is another point that is called a F. Okay, so F is called a focus or focal point. This is the exact center of this CP. CP is actually, what is CP? CP is the radius of sphere, right? CP is radius of sphere. CP is a radius of sphere. So this is called a radius of curvature. C is called a center of curvature. CP is called a radius of sphere. Okay, and F is the exact center of CP. That means I can write CP divided by 2. Okay, CP is the radius of curvature or radius of the sphere, that's divided by 2. That means the exact center. This is what is called a focus. This is F of concave mirror, and this is F of convex mirror. Okay, so these definitions are very important. So in your examinations, sometimes they will ask, what do you mean by spherical mirrors? So spherical mirror means these mirrors are a part of a sphere. That's why this is called a spherical mirror. Two types of spherical mirrors are, one is concave mirror, and another one is called a convex mirror. If the reflecting surface is inside of the sphere, then that is called a concave mirror. And if the reflecting surface is outside, then that is called a convex mirror. Okay, so pole, then you will discuss about pole, focus, and a center of curvature. C is called the center of the sphere. That is what is called a center of curvature. P is the center of the mirror. This is the mirror. Okay, this is the mirror. This is the concave mirror, and P is the center of this mirror. That point is called a pole. Okay, and if I will join C and P with an imaginary line, then that is called a principal axis. Principal axis. Then CP is called a radius of sphere, and finally F is called a focus or focal point of the sphere. So that's all about the spherical mirrors, and its uh, two types. Okay, then coming to the next is called the if the object is at infinity. Okay, so here you can see this is the object. AB is the object. if the object is at infinity, here you can see these are the rays. These are the rays. These are the light rays coming from the object AB. And see, these rays are parallel to the principal axis. If the object is at infinity, this is very important. If the object is at infinity, the rays coming from the object will be parallel to the principal axis. Okay, and it will come here on the, this is concave mirror because the reflecting surface is inside. These rays will come here and this will go to the focus or focal point. Okay, so here you can see these are the rays, and the rays are parallel to the principal axis. Why these rays are parallel to the principal axis? Because the object is at infinity. Infinity means far away from this mirror. Okay, that is what is called a infinity. Okay, so if the rays are parallel to the principal axis, then it will come and reach the concave mirror. Then after that, the rays will reflect and it will meet at a particular point called a focus or focal point. And here you can see this is the incident ray. This is the IR. I am writing here. This is the incident ray and IR1. Okay, this is first ray and this is the reflected ray. I am writing RR1. And here you can see this angle. You can see I and R. What is I and R? I is called angle of incidence. R is called angle of reflection. Okay, so this is very important. I is equal to R, law of reflection. Angle of incidence will be equal to angle of reflection. Okay, angle of incidence will be equal to angle of reflection. This is in the case of concave mirror. Then coming to the convex mirror. Okay, the second one is coming to the convex mirror. Okay, so again the object is at infinity. Okay, again the, okay, I will take another color. Yeah. Yeah, again the object is at infinity. AB is the object and the object is at infinity and the rays are coming like this. The rays are parallel to the principal axis. It will come and touch here. Then I told you if the rays are parallel, it will move to the focus. Here the focus is behind the this is convex mirror. Okay, as I already told you. For example, this is the sphere and the reflecting surface is outside. This is called a convex mirror. Convex mirror. Okay, and this point is P and here is center C and F is here. And here you can see P, F and C. This is P, this is F and this is C. If the rays are parallel to the principal axis, it will come to the focus, then it will be go back like this. That means if the ray will come like this, it will reflect like this. And again, this will follow the law of reflection. What is that? I is equal to R. What is I is equal to R? Angle of incidence will be equal to angle of reflection. Okay, this is the incident ray 1. This is incident ray 1. This is incident ray 1 and this is incident ray 2. So angle of incidence will be equal to angle of reflection. So this is in the case of convex mirror. Okay, and again one more point is that M in this part, this is the sphere and this is the mirror. Okay, part of sphere, and this point is M and this is N, and we call this Mn is called aperture. Okay, aperture. Mn is called aperture. Okay, so the point is that, okay, so the point is that uh, where the incident ray and the reflected ray so will meet, you will get image here. So for example, in the case of this concave mirror where the object is at infinity, you will get the image here, focus. Okay, then for example, in the case of convex mirror, if the image is at infinity, we will get image here behind the mirror. Okay, we will get, so this is the point where both incident ray and reflected ray intersect. Okay, so we will get the image here. Okay, behind the mirror. That's why this image is called a virtual image. Okay, in the case of concave mirror, we will be getting image at the front side. That's why this is called a real image. This is real image and this is called a virtual image. Then coming to the next one. Okay, then we will discuss the position of the object, and based on the position of the object, what about the position of the image, what about the size of the image, and what about the nature of the image. We will discuss one by one. We will discuss one by one based on the ray diagram. Okay, so consider this ray diagram. Okay, so consider this ray diagram. Here you can see this is the incident ray. Okay, this is the incident ray, and this ray, and this is the principal axis. I am writing here, this is the principal axis. Principal axis means it's an imaginary line passing through center of curvature and pole. So if the incident ray is parallel to the principal axis, I already told you the ray will pass through the through a point called a focus. This is called a focus. This point is called a focus, where this is the incident ray. So this angle is I, and this is the reflected ray. So that means this is called R. Okay. So this is the uh, angular bisector between these two rays. Okay. Yeah. For example, then this is in the case of concave mirror. In the case of convex, this is convex mirror. This is convex mirror, and this is P, this is F, this is C. I already told you this is the sphere, and this is the reflecting. Here is the reflecting surface is outside the sphere. So this is P, this point is F, and this point is C. So this is the incident ray, and the incident ray is coming like this. Here the incident ray is parallel to the principal axis. If the incident ray is parallel to the principal axis, it will move to the focal point, then it will reflect like this. So, and again, these two rays will follow the law of reflection. I is equal to R. Angle of incidence will be equal to angle of reflection. Then consider another case. Yeah, consider the next case. Here, this is the incident ray, and here the incident ray is passing through the focus. Okay, I already told you if the incident ray is parallel to the principal axis, then the ray will passing through the focus. Okay, so here the incident ray is passing through the focus, then the reverse will happen. If the incident, we know that if the incident ray is parallel to the principal axis, the reflected ray will be passing through the focus. So if the incident ray is passing through the focus, then the reflected ray will be parallel to the principal axis. Reverse, just reverse. Similarly here, this is the incident ray. This is the incident ray, and this incident ray is passing through the focus. Here you can see the ray will come here. The ray will come here, and we will intersect. We will extend this line to the focus. Okay, and if the incident ray is passing through the focus, I already told you the reflected ray will be parallel to the principal axis. This is the reflected ray. This is the reflected ray. The reflected ray will be parallel to the principal axis. Then another case is, this is the incident ray. The incident ray is passing through the center of curvature. If the incident ray is passing through the center of curvature, the reflected ray will also follows the same path. This is in the case of concave mirror. In the case of convex mirror, this is the incident ray. This is the incident ray, and the incident ray is passing through the center of curvature. The reflected ray will follows the same path. This is the reflected ray. Reflected ray. The reflected ray will also follows the same path. Okay. Then coming to the next case. Okay, so this is the incident ray IR. This is the incident ray, and this ray is coming to the concave mirror, and it will intersect here pole P. What happens is, and again we know that this is called angle of incidence, and the ray will be reflect like this. This is called R. This angle of incidence will be equal to angle of reflection. Then coming to convex mirror. This is convex mirror. This is convex mirror. This is the incident ray. This is the incident ray, and the incident ray is coming like this. It will meet here, point P. Then the ray will be reflect like this. And again, the angle of incidence will be equal to angle of reflection. I is equal to R. Angle of incidence will be equal to angle of reflection. Okay, so this is very important. Angle of incidence I is equal to R. Please remember this law. I is equal to R. Angle of incidence will be equal to angle of reflection. Then coming to the different cases. Next, we will discuss the different cases of image formation. First one is, okay. So these are the different cases of image formation in concave mirror. Okay, in concave mirror. Concave mirror. So concave mirror means the reflecting surface is inside. Okay, so the first case is if the object is at infinity. This is the object. AB is the object, and A is the top point of the object, and B is the bottom point of the object. So I am considering two light rays from these two objects, from the object at point A and B. Okay, one ray is from A. This is ray 1. I am writing here. This is ray 1, and another light ray from point B. This is ray 2. And here the object is at infinity. I already told you, if the object is at infinity, the rays are parallel to the principal axis. If the rays are parallel to the principal axis, it will come here to the reflecting surface. Then the light ray will be reflected back like this. Then it will pass through the point called a focus. Okay, so these rays will intersect here so that we will get image here. Okay, and what is the speciality of this image? This image is a point. Okay, this image is a point. That means the image is a point. And what about the size? It's diminished. Okay, it's not enlarged, it's not reduced. It's a point size image. Okay, and again, this image is real. Okay, not in the behind of the mirror. This image is in front of this mirror. Okay, so this is called a real. So this, if the object is at infinity, the image will be point sized, point sized and real. Then coming to the second case, if the object is not at infinity, it's just beyond C. Beyond C means center of curvature. Again, this is the object. This is the object, and A is the top point of the object, and B is the bottom point of the object. Okay, I'm considering two light rays from point A. One ray, this is ray 1. One ray is parallel to the principal axis, and another ray, ray 2 is passing through the center of curvature. We know that if the light ray is parallel to the principal axis, it will pass through the point called a focus. Okay, so this is the reflected. This is RR1. RR1 means reflected ray 1. Okay, then the second ray, the second incident ray is passing through center of curvature. As I already told you, if the light ray is passing through the center of curvature, it will be reflected back through the same path. Okay, so this line represents the reflected ray 2, and these two reflected rays will intersect here. So this is the image of A. That means A dash. Okay, I am considering point A, and we will get the image. This is the object. This is the point A of this object, and A dash is the image of this object. Okay, and we will be getting an inverted image because A dash is below principal axis. So A dash is the inverted image. So that means the image is inverted. Okay, so if the object is beyond center of curvature, the image, we will be get an image, and the image is inverted. That is one point. Then the second, and that is one point. Then the second point is, where is the position of the image? The position of the image is in between center of curvature and focus. Okay, so this is very important. If the object is beyond center of curvature, then the position of the image will be in between the center of curvature and a focus point or focal point, and the image is inverted. And what about the size of the image? You can compare the height of the object with the height of image. Here, the height of image is reduced. Okay, the height of image is not same as that of the height of the object. The height of the image is reduced. Okay, so I can say if the object is beyond center of curvature, then the image will be inverted. the image will be, the position of the image will be center of curvature and focus, and finally the size of the image is reduced. Okay, so this is what is called a magnification. We will discuss this later. So magnification means the enlarging or reducing the size of the image based on the position of the object. Okay, so height of image divided by height of object. We will discuss this magnification later. Okay, so again, so this is very important. If the object is beyond C, the image will be inverted. Then coming to the third case. Okay, so coming to the third case, here you can see this is the object AB, this is the object, and where is the object? So first case we discussed, the object is at infinity. Second case is beyond C. Then the third case, this is the third case. Third case means the object is at point C. That means at the center of curvature. Okay. Similar to the other previous two cases, I am considering two rays from point A. Okay, so one ray, this is ray one ray is parallel to the principal axis, and I'm considering another ray that is passing through focus. So ray 1 is parallel to the principal axis. We know that if the ray is parallel to the principal axis, it will be passing through the focus. So this is the reflected ray 1. So this is RR1. Okay, reflected ray 1 passing through the focus. And the second ray from A is passing through focus. If the incident ray is passing through focus, I already told you that will be parallel to the principal axis. Okay, so this is reflected ray 2. This is reflected ray 2. So this is reflected ray 1 and this is reflected ray 2, and these two reflected rays meet at here. That means this is the intersection. So this is the image of A. This is the image of A. That means A dash. So we will be getting the image of point A here, where on C itself. That means if the position of the object is at center of curvature, then we will be getting the image on that particular point, the center of curvature itself. This is another important point. Okay, and the image is inverted. That is another point. And what about the size of the image? The size of the image, this is the height of object HO, and this is the height of image. So HO is equal to height of object is equal to height of image. Okay, so this is another peculiar property, and again this image is real because the image is in front of this concave mirror. So that's why this image is called real. So sometimes in your examination the question will be like this: if the position of the object is at the center of curvature, then what are the characteristics of its image? Okay, so what are the characteristics? First one is the image will be at point C. Then second one is height of image will be equal to the height of object. Then the third one, the image is real and it is inverted. Then coming to the fourth case. Okay, so here the object is, this is the object AB, and this object is in between C and center of curvature and focus. So in this case, the object AB is situated in between the center of curvature and focus. Okay, I'm considering two rays. So first ray is, this is ray 1, this is ray 1, and this ray is parallel to the principal axis. This ray is parallel to the principal axis, and another ray, this is second ray 2, and this ray is passing through the center of curvature. We will consider the first ray. So the ray 1 is parallel to the principal axis. We already know that if the light ray is parallel to the principal axis, it will reflected through point. It will be reflected and passing through point F. Okay, so this is reflected ray 1, RR1. Okay, and the second ray is passing through the center of curvature. We already discussed that if a light ray is passing through center of curvature, the reflected ray will also follow the same path. Okay, and this path is the same path of the incident light. Okay, so these two rays will intersect here so that we will get the image of A here. This is the image of A. This is the image of A. Okay, and check the characteristics of the image. Here, where is the position of the object? Here, the object is situated in between C and F, center of curvature and focus. And we will be getting image here. Check the height of image and height of object. Okay. So the height of image will be more than the height of the object. That means the image size is enlarged. That means if the object is in between center of curvature and focus, the size of the image will be enlarged. That is one point. And the second point is the image is inverted, right? The object, see the top point of the object is above the principal axis like this. And where is the top point of the image? The top point of the image will be below the principal axis like this. That means the image is inverted. Okay, so the image is inverted. That is second point, and the image is real because this is in front of the mirror. That's why this is called real. Okay, so if the object is in between the center of curvature and the focus, the image will be where is the position of the image? The image will be beyond C. Okay, the image will be beyond C, and the size of the image will be increased. The size of the image will be increased. So the height of the image is more than the height of the object, and the image is real, and the image is inverted. Then coming to the fifth case. Okay, so coming to the fifth case, where is the object? Here the object is at point F. Here the object is at the focal point F. So again, I am considering two rays. Okay, this is ray 1. This is ray 1. Here the ray is parallel to the principal axis. If a ray is parallel to the principal axis, the reflected ray will be passing through the focus. So this will be the reflected ray. And I'm considering the ray number 2. This is ray number 2 passing through the center of curvature. If a light ray is passing through the center of curvature, the reflected ray will also follow the same path. That means we will get the object at infinity. Sorry, not object, image. We will be getting the image at infinity. Okay, so this is exactly the reverse of the first case we discussed. What we discussed? Okay, so in the first case, I told you if the object is at infinity, the image will be here. This is the image. Okay, and now in the fifth case, the object is here. The object is at focus. Object is at focus means we will be getting image at infinity. Okay, you understand? This is exactly what first case and fifth case are reverse, opposite, exactly opposite. So first case, the object is at infinity, we will be get the image on the focus. Fifth case, the object is at focus, then we will be getting image at the infinity. Then coming to the last case, sixth case. Okay, so this is the sixth case, and this is the object. Okay, this is AB. AB is the object. Okay, please remember AB is the object. Every time AB is the object. Okay, and where is the position of the object? Now the object is in between focal point, focus and a pole. Okay, now the object is in between focal point, focus and a pole. Okay, I'm considering the ray from A, and it will be passing through point P, pole. Okay, and it will follow the law. Angle of incidence will be equal to angle of reflection. So I will be getting reflected ray like this. So this is reflected ray 1. Then I will be considering another ray, second ray. This is incident ray 2. It will be passing through the center of curvature. So we already know that if a light ray is passing through the center of curvature, the reflected ray will follows the same path. So the same path will be the reflected ray. Okay. So here there is no intersection. So what I will do is I will extend the reflected ray like this. I will extend the reflected ray. This is the reflected ray. This is the extension of reflected ray 2, and this is the extension of reflected ray 1. These two rays will meet here. Okay, so this is the image. This is the image of A. So now the image will be behind the mirror. That's why this is called a virtual, not real. Okay, But in the other 5 cases, the image will be in front of the mirror. That's why that is called a real image. Here, the image is virtual because the image is behind the mirror. And again, this is not inverted. This is erect. This is exactly this is exactly similar to uh, uh, the position of the object. But the problem is the image is enlarged, right? It's magnified, so the height of the image will be more. So this is hi, this is hi, and this is ho. Okay, so height of the image is more than the height of the object. Okay, so what are the characteristics of this? If the object is in between focal point and P, the image will be behind the concave mirror, and the size of the image is more, and the image is virtual, not real. Okay, so these are the different cases of uh, 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 object and image formations, the image formations in concave mirror. So I will show you one table. Whatever we discussed, it is mentioned here in this table. I will show you one table here. Yeah. Okay, whatever we discussed, it is mentioned here. So first case is the object is at infinity. Okay, where is the position of the image? The image will be in the focus. Okay, so the reverse, the fifth case I told you. Okay, if the object is at infinity, we will get image at focus. If the object is at if the object is at focus, the image will be at infinity. Okay, you can easily study. If the object is at infinity, we will get image at the focus. If the object is at focus, the image will be at infinity. Okay. And another point is that if the object is at C, the position of the image will be at C. And again, there is no magnification. The HI will be equal to HO. Okay. HI, the height of image will be equal to height of the object. HI will be equal to HO. Okay. Then if the object is beyond C, that means between infinity and C. Okay, so the image will be between F and C, and the image will be diminished. Then if the object is between C and F, then the image will be beyond, the position of the image will be beyond C, and it will be enlarged. It will be enlarged. Okay, so at C we will be getting the same size. At C we will be getting the same size. Then between C and F, the size is enlarged. At focus, the size is enlarged. Between P and F, the size is enlarged. Okay, all the cases, the images are real. Only one case, the last case. Last case means if the object is between P and F, the image is virtual. Virtual means the image is behind the mirror. Okay, and erect. Okay, all other cases, the image, the characteristics of the image are real and inverted. Okay, the exceptional case is the last case, if the object is between P and F. And where is the position of the image? Behind the mirror. Last case. All the other cases, the image will be in front of the mirror. Okay, then coming to the next one. Yeah, ray diagram we discussed, different ray diagrams we discussed, angle of reflection. Yeah, these are some of the applications of concave mirror. As I already told you, here these rays are coming like this. The rays are at infinity, and this will be touching like this concave mirror, and it will be reflecting back, and it will be passing through the focal point. That means the rays are coming like this. Then it will be the reflected ray will be coming to the focus. That means focusing the light rays to one particular point. That's why in torches, okay, torches, you are focusing the light, right? Searchlights, vehicle headlights, shaving mirrors, sometimes dentist used to detect some cavities inside the teeth. Then in solar furnaces, to capture the sunlight and heat to a particular point, because in all the cases we are focusing the light rays. Okay, wherever we are focusing the light rays, we will be using concave mirror. Okay, we will be using concave mirror. So these are some of the applications of concave mirror. Then coming to the convex, next is the image formation by a convex mirror. Same principle. First case is if the object is at infinity. Okay, as I already told you, if the object is at infinity, the rays are parallel to the principal axis. So these are the rays are parallel to the principal axis. It will be passing through the focus. Here the focus is behind the mirror. So we will be extending line like this. That's why dotted lines. Okay, so then the ray will be reflected like this. So this is the reflected ray. Okay, so again, angle of incidence will be angle of reflection. Then this is one case if the object is at infinity. Then this is pole. Then next is beyond P. Next is beyond P. If the object is beyond P, this is the object AB. And I'm considering two rays. One ray is parallel to the principal axis, and another ray is passing through the center of curvature. We know that if the ray is parallel to the principal axis, it will be passing through the focus like this. Then here the focus is behind, so we will be extending like this using dotted lines. Then the ray will be reflected like this. Angle of incidence will be equal to angle of reflection. Okay. Then the second ray will be passing through the center of curvature, and we know that if the incident ray is passing through the center of curvature, the reflected ray will be passing through the same line. Okay. So here similar when we check with the previous case like concave mirror, there is no intersection between the two reflected rays, right? So we have to extend. Where is the first reflected ray? This is the reflected ray 1. This is the reflected ray 1, RR1. Okay, and this is the reflected ray 2. Okay, so the intersection will be here. That means the image will be here. Okay, so the image will be behind the convex mirror. The image will be behind the convex mirror. That means the image is virtual. Okay, the image is virtual and it is diminished and it is erect. Okay, not inverted. Okay, so I will show you one table. Whatever we discussed, it is mentioned here in this table. Okay, so there are two cases. First case is the object is at infinity. Okay, so the object is at infinity means the position of the image will be here is the intersection. So we will get image here at the focus behind the mirror, and it is highly diminished because the image is here, highly diminished and point sized, and it is virtual. Virtual means the image is behind the mirror and erect. Then the second case is between infinity and the pole of the mirror. This is the object. This is the object, and here is the infinity, and the object is in between infinity and pole of the mirror. So we will be getting the image between pole and F. So we will be getting pole and F. We will be getting image between pole and F. So this will be the image. Okay, and behind the mirror. And what about the size? The size is diminished. So this is HI. Okay, and this is HO. So the size of the height of the image will be small when we compare with the height of the object. And it is virtual. Why? Because the image is behind the mirror and it is erect, not inverted. So that's all about the formation of image by concave mirror and a convex mirror. Okay, so sometimes the questions will be like this. What do you mean by principal focus of a concave mirror? Then the radius of curvature of a R is equal to 20 centimeter. What is the focal length? Okay, as I already told you, this is the spherical mirror, and this is C and this is P, and we have to calculate F. Okay, what is CP? CP is called as radius of curvature. Radius of curvature is 20. So the focal length will be 20 by 2, right? Focal length will be take 20 by 2, that is equal to 10 centimeter. So this distance is 10 centimeter. What is its focal length? Means it's 10 centimeter from pole or center of curvature. Name a mirror that can give an erect and enlarged image of an object. Okay, so erect. Okay, not inverted. Name a mirror that can give erect and enlarged image of an object. Another question. Then why do we prefer convex mirror as a rear view mirror in vehicles? So these are some of the application types of problems you can expect in the examination. Then, yeah, next topic is the sign convention. Next topic is called sign convention. Sign convention. This is very important. Okay, this is to solve problems in problems using mirror formula and magnification. Okay, so this is the mirror. This is the mirror. As I already told you, this is the mirror, and Mn is called aperture, and this is the principal axis. This is called the principal axis. Okay, and here above the principal axis, for example, this is the object. For example, this is AB, so that means HO. HO is the height of object, and this is image, so this is HI. Here you can see the object. The object height is like this. That means it is above the principal axis. So the sign will be positive. For example, in a question, it is given that the object size is 20 centimeter. That means you should write HO is equal to plus 20. Okay. Then and the image will be below the principal axis, means the sign will be negative. The sign will be negative. And here, this is the reflecting surface, right? This is the reflecting surface. For example, this is a concave mirror, and this is the reflecting surface, and this distance is negative. This distance is negative, and this distance is positive. Okay, this is like you can where is the reflecting surface? Here is the reflecting surface, right? Here is the reflecting surface. So the side near to the reflecting surface will be negative. Just remember this thing. This is negative. This is positive. Okay. Where will be the reflecting surface? So the sign will be negative. Okay, not positive. Okay, so above principal axis positive, below principal axis negative, reflecting surface side is negative, reflecting the opposite side of the reflecting surface will be positive. Okay, so this is the sign convention. This is very important to solve problems. Then coming to the next one, that is the mirror formula. This is very important. That is called a mirror formula. So the equation is 1 by F is equal to 1 by U plus 1 by V. Okay, this is the equation. So where F is called focal length, and U is called object distance. U is called object distance, and V is called image distance. Image distance. F is the focal length. Then this is very important. Then another equation is magnification. So magnification we already discussed. Based on the position of the object, the size of the image will be either enlarged or same size or reduced. So based on the position of the object, this is what is called a magnification. So how you will calculate the magnification? There is an equation. Magnification M is equal to height of the image HI divided by HO. This is the equation. So minus V by U. This is the equation. Magnification M is equal to HI divided by HO. That will be equal to minus V by U. Minus V by U. Okay, we will apply these two equations to solve problems in related to this chapter. Okay, so we will discuss one problem. So first one is a convex mirror. So the mirror is convex. So I will draw a convex mirror like this. Okay, so like this. Okay, so reflecting surface is here. Okay, this is the reflecting surface, and this is the principal axis, and this is P, this is F, and this is C, where P is the pole, F is the focus, and C is the center of curvature. A convex mirror is used for rear view on an automobile, has a radius of curvature. Radius of curvature means CP. This will be equal to 3 meter. Radius of curvature is CP. R is equal to CP. CP is equal to 3 centimeter. If a bus is located at 5 meter from this mirror, okay, so a bus is here like this. Okay, this is the bus at a distance of 5 meter. Okay, that means bus means this is the object. Okay, so bus means this is the object. So that means object distance is given. So we have to apply the sign convention. So this is the principal axis. We know that above principal axis is plus, below principal axis is negative. Reflecting surface is here. Reflecting surface is here means this is negative and this side is positive. Okay, so So first we will write the given data. R is equal to what is R? R is PC. That means PC is on the other side, right? That means plus 3 meter. R is equal to plus 3 meter. Then coming to the object distance. What is object? Object is U. Object is U and image is V. Okay. So object is here. Object is this side, right? What is the sign convention here? Minus, negative. So that means minus 5 meter. So U is equal to minus 5 meter. We have to calculate V, find the position, nature, and the size of the image. You have to calculate V, then nature and the size of the image. Size of the image means you have to find magnification also. Okay, so we have the equation 1 by F is equal to 1 by U plus 1 by V. Okay, so to apply this equation, we need which one? F. Okay, how you will calculate F? Okay, F is the exact center of this CP, radius of curvature, and we know that radius of curvature. Radius of curvature is 3 meters. So 3 divided by 2. 3 divided by 2 is the focal length, 1 by 5. And what is the sign? Again, F is on this side. F is on this side means, I already told you, this is the opposite side of the reflecting surface. Reflecting surface means it's positive. So this is F. So you can give F is equal to plus. So that means 1.50. So now you have F and you have V. So solve this equation, you will get the value of V. Okay. So you will get V is equal to 1.15 meter. Okay, so now you have U and V, then you can apply the magnification. M is equal to, what is that? HI divided by HO, or is equal to minus V by U. Okay, so that will be minus 1.15 divided by what is U here, minus 5. Okay, solving this equation, solving this values, you will get magnification is equal to 0.3. Solving this, you will get a magnification is 0.3. Okay, and this is a convex mirror, right? So this is the reflecting surface. This is the reflecting surface, and this is P. This is F, and this is C. So where is the position of the image? The position of the image will be behind the mirror, right? So that's why this is virtual, right? And again, it's erect. I already told you this is erect, and the size will be small. Why the size is smaller? Because the magnification factor is only 0.23. Okay, so 0.23 means if the magnification factor is less than 1, that means the size will be smaller. Then coming to the next one. Next problem, exactly similar to this. An object, it's a concave mirror, okay? So I will draw a concave mirror like this. So this is a reflecting surface is inside. Reflecting surface. Reflecting surface is inside. This is the pole. This is the pole P. This is F, and this is C. So an object 4 centimeter in size is placed at 25 centimeter in front of the concave mirror. Okay. So object is object is somewhere here. So I will be marking like this AB. Object is here. And what is the size of the object? So size of the object is 4 centimeter and at a distance of 25 centimeter. Okay, so that means HO is given, right? Height of the object is 4 centimeter. What is the sign? You have to apply sign convention, right? This is above the principal axis. Above principal axis means you should give plus. Okay, so HI will be equal to, sorry, before that, then object distance is U. Okay, this is the reflecting surface. So reflecting surface is this, means this is negative and this is positive. Okay, so this is the reflecting surface. That means minus 25 centimeter. So U is equal to minus 25 centimeter. Then what is that? Focal length. F is equal to 15 centimeter. Again, F is in front of the mirror. F is in front of mirror means what is the sign? Minus 15. Okay, minus 15, because F is here in front of the reflecting surface, so it's minus 15. At what distance from the mirror should a screen be placed in order to obtain a sharp image? So you have to find the image distance. Image distance is V is equal to question mark. Find the nature and size of the image. You have to find the image distance, and also you have to find the size of the image. Size of the image means hi. Hi is equal to question mark. Hi is equal to question mark. Okay, we have two equations, right? What are the two equations? 1 by f is equal to 1 by u plus 1 by v. Okay, then from this we have f, right? We have f, then we have u. Yes, so from this you can calculate v. Okay, by substituting all the values you will get v. Okay, you can calculate the value of v. So let me check what is the value of v. Yeah, so the value of, after solving this equation, you will be getting v is equal to minus 37.5 centimeter. Then you can apply m. What is m? Height of the image divided by height of object is equal to minus v by u. Okay, so you can write like this: hi by ho is equal to minus v by minus u. Minus v by u. Okay, so from this hi is equal to minus v into ho divided by u. Okay, so after solving this, you will be getting minus 6 centimeter. Okay, so the height of image is minus 6 centimeter. Okay, let me check. It's yeah, so you have to find the nature of the image, right? Here here where is the focus f? So this is the concave mirror. Okay, and this is p, this is f, and this is c. Where is the object? Object is at a distance of 25 centimeter, right? 25. Okay, f is at a distance of where 15, right? 15. Okay, so that means c will be here. Okay, so that means object is, so this total length, we know that this total length is 30 centimeter, right? Because this is p to f is 15, f to c is also 15. 15 plus 15, 30, right? That means the object is in between c and f. If the object is at c, then the size of the image will be same. If the object is in between C and F, we already discussed, the size of the image will be enlarged. Okay, and we will be getting image below the principal axis. That means inverted. So what about the nature of the image? So the nature of the image will be the height of the image is inverted and enlarged. The image is inverted and enlarged. Okay. Yeah. So these are some of the problems related to mirror formula and magnification. So there are some questions. See this question: a ray of light. Here you can see this is the incident ray on a spherical mirror at a pole P. Okay, so you should select the correct reflected ray. Okay, we know that we already discussed the angle of incidence will be equal to angle of reflection. So this is I, this is R. So the reflected ray will be like this, right? So this is the reflected ray. The reflected ray will be like this because angle of incidence will be equal to angle of reflection. Then coming to the next one. Yeah, next one. Again, we already discussed these type of problems. Here, a ray of light is incident on a spherical mirror after passing through the center of curvature C. Okay, so this is the incident ray. If the incident ray is passing through the center of curvature, then the reflected ray will follows the same path. Okay, so the reflected ray will be like this. Okay, so this is the reflected ray. This is the path of the reflected ray. Then another question: if the incident ray, this is the incident ray, this is the incident ray. If the incident ray is passing through the focus, we already discussed this. If the incident ray is passing through the focus, then the reflected ray will be passing parallel to the principal axis, right? This is the principal axis. Principal axis. If the incident ray is passing through the focus, then the reflected ray will be parallel to the principal axis. So this is the reflected, this is the path of the reflected ray. Then another question. Yeah, this is another question. A ray of light is incident on a spherical mirror in the direction towards the center of curvature. Yeah, this is the incident ray. Okay, the incident ray is passing through the center of curvature. We know that if the incident ray is passing through the center of curvature, the reflected ray will follows the same path. So the path of the reflected ray will be like this. This is the path of the reflected ray. Then another question. Yeah, yeah. Another question is like this. An object is placed at the center of curvature. Here, this is the object, and the object is placed at the center of curvature of a concave mirror. Okay. You have to select the correct characteristics of the image formed by the mirror. We know that if the position of the image is at the center of curvature, the size of the image will be exactly same as the size of the object. Hi will be equal to Ho. Okay, and we will be getting the image on the center of curvature itself, and the image is inverted, right? So there are four options. From the four options, the correct answer is the image. The image is the same size as the object. The image is the same size as the object. Okay. Then coming to the next one. An object is placed between the focus and pole P. This is the object. Okay. An object is placed between the focus F and P of a concave mirror. We already discussed this. We will be getting image behind. We will be getting image behind the mirror. So the correct answer is so the image is virtual, not real. So the correct answer is the image is virtual. Then next question. An object is placed in front of a convex mirror. So this is the object. Okay, so this is the object on its principal axis. Choose the correct characteristics of the image formed by the mirror. So we will be getting, so the rays are coming like this, and the rays are intersecting behind the mirror. So the size will be diminished. Okay, this is a convex mirror, so the size will be diminished. We will be getting the intersection behind the convex mirror. So the image will be behind the convex mirror. So the image is diminished in size. So the correct answer is the image is diminished in size. Then another question is, a pencil is placed between the center of curvature C and F of a large concave mirror. Okay, so this is the concave mirror. Okay, so I will be drawing a concave mirror. Okay, so this is the concave mirror, and here is the reflecting surface, right? Here is the reflecting surface. Okay, and this is the P and pole, focus, and center of curvature. See, so a pencil is placed between the center of curvature and focus of a concave. So the pencil is here. Okay, so this is the object. This is pencil. A pencil is placed between the center of curvature and focus of the of a large concave mirror. Choose the correct characteristics. Okay, so we will be getting image. We will be getting image in front of the mirror, so it is real. Okay, it is real. We will be getting image below the principal axis, so it is inverted. And if the object is at C, we will be getting the exact size. The image size will be same as that of the object. If the position of the object is between C and F, or between F and P, the image will be enlarged. That means magnified. So the correct answer is the image is real, the image is inverted, and the image is magnified. Then another question is, okay, so this is related to sign convention. Okay, this is related to sign convention. We have we have to apply the sign convention: object distance, focal length, and image height. Okay, okay, I will write here object distance, then focal length. Okay, object distance, focal length, and then Object distance, focal length, and image height. Okay, and image height. Okay, is it plus or minus? Sign convention, because sign convention is very important, otherwise your answer will be wrong. Here, where is the object? Okay, here this is a the bulge side of a shiny spherical bowl is held close to a candle kept to its right. Okay, this is the here this is the candle and this is the object. A diminished virtual image forms behind the convex. This is a convex mirror. This is a convex mirror, and a convex mirror means the reflecting surface will be outside. Here is the reflecting surface, and we know that this, if this is the reflecting surface, then this side will be negative, this side will be positive. Okay, and above principal axis will be positive and below principal axis will be negative. So first of all, the object distance. Object is here. That means this is the reflecting surface. So that means this is negative. Okay, object distance is negative. So focal length is focal length is here behind the mirror. So it will be positive. And image height, where is the image? Image is behind the mirror, and this is the image height. The image height means it is above the principal axis. That means positive. So these are the, like this you have to apply the sign convention. So the object distance is negative, focal length is positive, image height is positive. Okay, then another one. Okay, okay. So I will write here object distance. What are the options? Object distance. Let me check. Object distance, focal length. Yeah, object distance, focal length, image height. Object distance, object distance, focal length, then image height. Okay, so a ball B, a ball labeled O, where is, yeah, this is the object. Okay, ball is the object. Okay, this is the object. Is placed 9 centimeter in front of a concave mirror. This is the concave mirror, means this is the reflecting surface, right? This is the reflecting surface. That means this is negative, this is negative, this is positive. Okay, so the above principal axis is positive, below principal axis is negative. So that means object distance is minus, object distance is negative. Then focal length is here, focal length is again negative, because focal length is near to the reflecting surface. Then image height, where is the image? Where is the image? Yeah, this is the image. Image is means above principal axis, that means plus. Okay, so minus, minus, plus. So object distance is minus, focal length is minus, image height is plus. Okay, then another one. Object, focal length, image distance. Okay, once again. Object, object distance, focal length, then image distance. Image distance or image height, I think. Image height, right? Image height. Let me check. Okay, let me check. Object distance, focal length, image distance. Okay, not image height, image distance. Okay, I will correct it. Image distance. Okay, so here, this is the object. Okay, so here, this is a concave mirror. This is a concave mirror, and this is the object. Okay, this is the object. You can see this is the object. This is a concave mirror. Concave mirror means this is the reflecting surface, right? Reflecting surface means this is negative and this is positive. Okay, above principal axis is positive, below principal axis is negative. Okay, so object distance is negative, right? Then focal length is this side, again negative. Then where is the image? Image is the other side. Image distance is positive. Image distance is positive. Okay, again object height, focal length, image distance. Object height, focal length. Object height, focal length. Object height, focal length. Object height, focal length, image distance. Object height, focal length. Object height, focal length, image distance. Okay. Okay, a pin is placed on the principal axis in front of the, again, convex mirror, right? This is a convex mirror means this is the reflecting surface. This is the reflecting surface means this is negative, this is positive. Above principal axis is positive, below principal axis is negative. Okay, so object height means positive because this is above principal axis. Then focal length is this side. So reflecting surface is here. That means it's again positive. And image distance, where is the image? Image is here. Image is on the opposite side of the reflecting surface. That means positive. Okay, all are positive. All are positive. Then an object is placed at the center of curvature of a concave mirror. We already discussed this. If the object is at the center of curvature, we will be getting image here, and the height of the image will be equal to the height of the object. Okay, so the answer will be option C. The image is the same size of the object. So the answer will be the image is the same size of the object. Then coming to the next one. Yeah. Again, this is related to sign convention. Object distance, focal length, object height. Okay. Object distance, focal length, and object height. Okay, it's a concave mirror. Concave mirror means a reflecting surface is this. Okay, this is the reflecting surface. This is the reflecting surface means this side is negative, this side is positive. And above principal axis is positive, below principal axis is negative. Okay, so object distance, where is the object? Pencil. Pencil is the object. This is the object. Okay, object is near to the reflecting surface. That means negative. Object distance is negative. Object distance is negative. Then focal length. Focal length is near to the reflecting surface, again negative. Then object height. Where is the object? Object height is, this is HI. Sorry, HO. This is object means HO. So HO means above principal axis means positive. Positive. So object distance is negative, focal length is negative, and object height is positive. Okay. So here, this is the incident ray. Okay. And the ray of light is incident on a spherical mirror at the pole P. We know that it will be reflected like this, and angle of incidence will be equal to what? Angle of reflection. So the reflected ray will be like this. Okay, so this is the answer. Okay, Ravi wants to design a solar furnace that will focus sunlight at one spot to heat water. As I already mentioned, torch lights, search lights, where we are focusing light to a particular point. Okay, the object is at infinity, and the rays will be coming like this. Then it will be reflected on the concave mirror, and that will be, the reflected ray will be traveling through the focus. Okay, that means we will be focusing to a particular point, or we will be focusing the beam of light. So if there is a term related to focusing, then you can directly choose the answer as what? Concave mirror. Concave mirror. So the answer will be concave mirror. No need to think anything. Okay. When you see a term focus, okay, focus sunlight or focus light rays or something, you can directly write the answer. The answer is concave mirror. Okay. So the question is like this: Ravi wants to design a solar furnace that will focus sunlight at one spot to heat water. So the answer will be here. his requirement is to focus sunlight at one particular point. Okay, we already discussed this. If the object is at infinity, means the light rays will coming from infinity. Okay, if the light rays are coming from infinity, the rays are parallel to the principal axis and it will be traveling through the focus. So that means the light rays will be focusing to a particular point. That means the answer is concave mirror. Concave mirror. Yeah. Then another question is, an object is placed between the focus and the pole of a mirror. We already discussed, if the object is at center of curvature, the size of the image will be same and we will be getting image on that particular point, center of curvature. If the object is between C and P, or in F, or in between F and P, the size of the image will be uh, the size of the image will be there are three cases, right? C, between C and F. If the object is in between C and F focal point, the image will be enlarged. Okay, and again, if the object is at point F, again the image will be enlarged. Okay, and we will be getting at infinity. But in the case of if the object is between F and P, the image will be behind the mirror. That means virtual. So the answer is virtual. So the answer is virtual. Okay. Yeah. Then we will be discussing the mirror formula problems. What is the object distance u? Okay. So here the question will be like this. This is image. This is image, and this is the reflecting surface. Okay, this is the reflecting surface, means this is negative and this is positive, right? So above principal axis is positive and below principal axis is negative. So here image distance means V. So V is equal to minus 56. Then F is equal to minus 21. Then you have to find what is the object distance U. We have the equation. What is the equation? 1 by F is equal to 1 by U plus 1 by V. So we have F, we have V. So solving this equation, you will be getting U. Direct substitution and solve it. So the answer will be, what is the answer? Yeah. So the answer is minus, this is the answer, minus object distance is, so this is the object distance. Object distance is minus 33.6 centimeter. Next question. Okay. Again, a concave mirror. Okay. Concave mirror means this is the reflecting surface. This is the reflecting surface, and means this is negative. This is positive. This is above principal axis is positive. Below principal axis is negative. Okay. So we have to calculate the image distance V. Okay. What is V? Here object is given. Okay, so object is U is equal to minus 12, because this is the reflecting surface. This is negative minus 12, and F is also minus 15. So apply the equation. 1 by F is equal to 1 by U plus 1 by V. 1 by F is equal to 1 by U plus 1 by V. So from this we can calculate the image distance V. Okay, you know F, you know U. What is F? F is equal to minus 15, U is equal to minus 12. Substitute it and solve it, you will get the value of V. What is V? What is the value of V here? Let me check. Yeah, the answer is 60 centimeter. Once you solve it, you will get image distance is 60 centimeter. Then coming to the next question. Okay. Here, it's a convex mirror. This is a convex mirror, means reflecting surface is this side. This is the reflecting surface. Okay. Reflecting surfaces means this is negative and this is positive. Above principal axis is positive. Below principal axis is negative. Find the focal length of the mirror. So object is given. So object distance U is equal to This is a reflecting surface, means this is negative, minus 30 centimeter. And image V is equal to, this side is plus 10 centimeter. So you can calculate 1 by F is equal to 1 by U plus 1 by V. You know U and V, just to substitute it and simplify it, you will get the answer F. So F is equal to, so the answer is F is equal to 15 centimeter. You will get the answer F is equal to 15 centimeter. Okay. Then next is we have you have to calculate F. So this is a concave mirror. Concave mirror means this is the reflecting surface. This is the reflecting surface. And reflecting surface means this is negative, this is positive, and above principal axis is positive, below principal axis is negative. Okay. So object is distance is given. So U is equal to, this is reflecting surface and this is negative. So minus 22.5. Then where is the image? Image is again the same side. So image means V. So V is equal to minus 15 centimeter. Okay, find F. So again, you can apply the equation 1 by F is equal to 1 by U plus 1 by V. You know U, you know V. Substitute it and simplify it, you will get the answer. So the final answer is, so once you solve it, you will get the answer. F is equal to minus 9 centimeter. So this is the answer. F is equal to minus 9 centimeter. So try all the problems. Then another question. Okay. So again, this is a concave mirror. Okay, this is a concave mirror, means this is the reflecting surface, RS, reflecting surface. This is reflecting surface, means this is negative, this is positive, and above principal axis is positive, below principal axis is negative. Okay, so here this is the object, right? This is the object. Object distance is given, that means U. So U is equal to minus 12. Then image V is given, V is equal to minus 48, because this is the reflecting surface and this side is negative. Okay, and HO is given, right? HO, height of object is given 3 centimeter plus 3, because this is above principal axis. Okay, so you have to find HI. Okay, we have to calculate HI. So we know the equation HI by HO is equal to minus V by U. Okay, so HI will be, HI is equal to HO into minus V by U. Okay, you know all the values. You know U, you know V, you know HO. Just to substitute it and simplify it, you will get the final answer. So the final answer will be, yeah. So HI will be minus 12 centimeter. This is the answer. HI is equal to answer. HI will be equal to minus 12 centimeter. Okay, then next is during an experiment with a concave mirror, these are the observations. HO is this, HI is this. What is magnification? We know the magnification. What is the equation? HI divided by HO. That will be equal to 14.4 divided by minus 4.50. Once you solve it, you will get the magnification is minus 3.2. So the answer is minus 3.2. Okay, so the remaining problems, just I am explaining. You can solve this problem. Find the object distance U. Okay, so 12 centimeter long pencil. So this means HO. HO is equal to 12 centimeter. You have to apply the sign. Sign convention is important. Sign convention is placed in front of a convex mirror. Okay. So convex mirror means I will draw a convex mirror like this. Okay, this is the convex mirror, means this is the reflecting surface, right? Here is the reflecting surface. So this is P, this is F, this is C. Reflecting surface, this means this is negative and this is positive. So in front of a in front of a convex mirror means it's minus 12, right? A 2 centimeter long virtual image forms above the principal axis. So that means HI above the principal axis means plus 2 centimeter. and 10 centimeter behind the mirror. 10 centimeter behind the mirror means V. So V is equal to, behind the mirror means here. So the image will be here. So V is equal to, what is the sign? Plus 10. Find the object distance U. Okay, so we know, you know the magnification equation. What is that? HI by HO is equal to minus V by U. So here you are calculating U, right? So U will be equal to, just cross multiplication, minus V into HO divided by HI. So you know so you know V, you know HI, you know HO. Just to substitute it, you will get the value of object distance. Okay, so the final answer will be, so the object distance will be minus 60 centimeter. This is the answer, minus 60 centimeter. Okay, so same way you can apply these equations to these problems. Again, this is another problem, concave mirror. So this is the concave mirror. Concave mirror means this is the reflecting surface, RS. Okay, so this is P, this is F, and this is C. Magna places an object. Okay, so this is object 18 centimeter in front of the mirror. So this is a reflecting surface means this is negative, this is positive. Above principal axis is positive, below principal axis is negative. Okay, so this is in front of the concave mirror means minus 18. So that means object means U is equal to minus 18. She observes that a 4 centimeter high, so image, that means HI, inverted image, HI means below, that means minus 4, 14 centimeter in front of the mirror. In front of the mirror means V is equal to, this side is negative, so minus 14.4. So find the height of the object HO. So we know the equation HI by HO is equal to minus V by U. So from this you can calculate HO. What is HO? HO will be is equal to HI into U divided by, so cross multiplication, HO will come here, HI into U divided by minus V. So you know HI, you know U, you know V. Just to substitute it, you will get the final answer, height of the image, HO. So the final answer equals, HO equals what? HO equals to 5 centimeter. So the final answer is 5 centimeter. Okay. Yeah, here a spherical mirror produces an image with a magnification. Magnification M is equal to 0.60. Magnification is less than 1. Magnification is less than 1 means the image is diminished. Okay, if the magnification is more than 1, that means enlarged. This is plus 0.60, right? So that means it's diminished. So here the magnification is M is equal to minus 1.8. So minus 1.8 means, so negative means, negative indicates that the image is inverted. Okay, so it's inverted. The image is real and inverted. So these are the some of the problems. You can use magnification equation. M is equal to HI by HO and calculate the magnification. Okay, sometimes some problems you have to apply both equations. 1 by f is equal to 1 by u plus 1 by v, and m is equal to hi by ho equals minus v by minus u. Okay, here you have to calculate hi. You have to calculate hi. All the datas are given. So solving it, finally you will get the answer. Hi will be equal to 0.6. Height of the image equal to 0.6 centimeter. Okay, so that's all about this topic, light reflection. So the important topics related to this chapter is, first one is the spherical mirror. What do you mean by spherical mirror? What is called a pole, what is called a center of curvature, what is called a radius of curvature, what is called aperture, then what is focal point, then the ray diagram, it is very important, and the position, nature, and size of the image based on the position of the object. There are different cases for concave mirror. First case is the object is infinity. Second case is the object is beyond center of curvature. Then third case, the object is at center of curvature. Then next case is the object is between center of curvature and focal point. Then next case is the object is at a focal point. And last case is the object is in between the focal point and pole. Okay. Then you have to, every time you have to explain with the help of a ray diagram. Okay. Then after that, sign convention, yeah, again, the image formation in convex mirror. Okay, first one is object is at infinity, and the second one is object is in between pole and infinity. Okay, law of reflection is important. Angle of incidence will be equal to angle of reflection. Okay, then after that, sign convention is very important. Sign convention. Okay, so the sign near to the reflected surface will be negative, and the side opposite to the reflected surface will be positive. Above principal axis, sign will be positive. Below principal axis will be negative. Then we have two equations. One is mirror formula. 1 by f is equal to 1 by u plus 1 by v. And finally, magnification, m is equal to height of image divided by height of object equal to minus v by minus u. Okay. So by learning all these terms and equations, you can solve any type of problems in this chapter, light reflection. Thank you.